Alright, good morning, good afternoon, good evening, anybody watching me. My name is Mr. Manuel, hosting this program, Mass Academy Ghana. Make sure you do all to subscribe to the channel. Don't just watch this video for free. Alright, so as I said previously, today's lesson is going to be on laws of indices, right? Laws of indices. As usual, we have to copy the notes, right? So something short for you, make sure you copy in 5, 4, 3, 2, pause the video and copy 1. Alright, if you've copied the notes, congratulations. Let us head to the explanations. Alright, so laws of indices. The first statement: these are sets of principles. So the laws are the set of principles that helps us to expand complex index notation questions involving multiplication and division. So this particular topic, that is laws of indices, will be revolving around multiplication and division most at times. And what we are saying is we will be given complex index notations. It being complex means you are going to be having either multiplication or division or combine. Alright, so these properties or these rules or these principles are the ones that are supposed to help you find for the answers during any complex index notation questions. Alright, so let's look at law 1. The first law, it says to multiply numbers in the same base, add the powers and maintain the base. To multiply numbers in the same base, add the powers and maintain the base. That is, when you have a exponent m times a exponent n, you realize that they have the same base but they have different exponents. What you do is you maintain the base and then you add the powers. It works only for multiplication of numbers in their index forms with the same base. All right, so when they have the same base and they are multiplying, just add the powers and maintain the base. Very easy, right? Law number 2: to divide numbers written in the same base, subtract the powers and maintain the base. Subtract the powers and maintain the base. So as we did in multiplication, we added. In division, we are going to subtract. So always remember, in multiplication we add, in division we subtract. So when you have the same base, dividing, we maintain the base and then we subtract the exponent. Very easy. So keep it in mind that anytime you are multiplying, we add the base. Anytime you are dividing, we subtract the base. That is very good. The last law, other laws are going to come, but they are not really prioritized, so that is why I didn't add them. They will come alongside our studies. All right, now it says whenever you have a number raised to the power something, right, and the whole thing is also raised to another exponent, what you are expected to do is you just multiply the exponents and you get your answer. So let's say a exponent m, that's index notation, exponent m will give us a exponent m times n. So whenever you see something like this, it means multiply this and this. All right, and the same thing applies to this: a exponent y, b exponent t, all raised to the power n. Y multiplies the n, t also multiplies the n. Y multiplies the n, t also multiplies the n. As simple as that. All right, now once we are done with the explanation of the notes, we are going to head towards trials as usual. So we are going to solve examples that revolve around this concept. All right, I'm going to help you solve the first one as usual, and probably the second one will be solved by you. All right, this is example 1. Now these examples I've given you is revolving around law number 1, law number 2, and law number 3. All right, it's very simple. So I'm going to help you solve this, and I'm going to give you a similar set of examples that revolve around the same concept. All right, so example 1, I'm going to do it with you. Remember, in law 1, when you are multiplying and you have the same basis, we add the powers. As simple as that. So for this one, 2 exponent 2 times 2 exponent 3 Since they are multiplying with different exponents by the same base, we maintain the base and we add the powers. And what are we going to get? 2 plus 3 gives us, so 2 exponents 5. And when we expand 2 exponent 5, what are we getting? 2 multiplying itself 5 times. Don't forget this. 2 times 2 times 2 times 1, 2, 3, 4, 5. When 2 multiplies 2, what are we getting? 4. Times 2 multiplies 2, we are getting 4. Times 2. 4 by 4 gives us 16 times 2. Let's multiply 16 by 2. Let's do it together. 16 by 2. 6, 2 gives us 12. 2, 1, 2. Plus 1 gives us 3. So 16 by 2 gives us 32. That is very simple. Let us take the second one. That is number 2. Number 2. X exponent 2 times x exponent 3. Remember, we are multiplying the same bases, right? So we maintain the base for multiplication, we add the powers. And then 2 plus 3. X exponent 2 plus 3 gives us 5. X is not a number, so we can't expand. So you leave your answer as it is. The third one, 5 exponent 2 times 5 exponent 3. We have the same bases but different exponents. So 5 exponents, you maintain the base and you add the powers. So we have 2 plus 3, which gives us 5 exponents 5. We can simplify this. 5 multiplying itself 5 times. So we have 5 times 5 times 5 by 5 by 5. Are we okay? So we have 5 times 5 giving us 25 times 5 times 5 gives us 25 times 5. Alright? Now let's multiply 25 by 5. Sorry, 25 by 25. So we have 25 by 25. 5 5 gives us 25. 5 2 gives us 10 plus 2 we have 12, right? 5 2 gives us 10, we have 0. 1 2 2 gives us 4 plus 1 gives us 5. We have 5 2 6, so we have 625. So 25 by 25 gives us 625 by 5. Now let's multiply 625 by 5. We have 5 5 25. 5 2 gives us 10 plus 2 is 12. 2 1 5 6 gives us 30 plus 1 31. So we have 3 1 2 5. That is very good. The fourth one, that is 2 exponent 4 divided by 2 exponent 2, right? Remember, for the second law, it says when you are dividing, you subtract the exponents. So we maintain the base and then you subtract the exponent. So we have 2 exponent 4 minus 2 gives us 2. We can simplify 2 exponent 2, right? 2 multiplying itself 2 times. So 2 times 2. 2 by 2 gives us 4. That is our answer. Very easy. Let's go to the fifth one. It is the same division. They are just writing it in a different form, alright? The same division. So x exponent 5, you can even write it this way, divided by x exponent 2. Once we are dividing with the same base, we maintain the base and we subtract the exponents. What is 5 minus 2? 5 minus 2 gives us 3, right? So x exponent 3. As we did earlier on, that was with this. X is just a variable, so we can't, expand and then find our answer for this, alright? Let's go to the sixth one. The sixth one has to do with the third law, right? Exponent 5. I told you whenever you have a number in its index notation and it has another exponent, it means you have to multiply the exponent. So we maintain the base 4 times 5, and 4 times 5 gives us 20. Expand this and tell me the answer in the next video, alright? So you're going to multiply 2 times 2 times 2 20 times. All right, I'm not going to do this with you, pardon me. Right, let's go to this. So the seventh one, we have 2 exponent 3, 3 exponent 2, all to the power 2. Now, as he said in the third law, I give another example that was similar to this, right? So whenever you have a number exponent 3, another number to an exponent, all raised to another exponent, the exponent multiplies the exponent inside the bracket, right? So we have 2 exponents 3 times 2, and then 3 exponent 2 times 2. And we are going to get 2 exponent 3 by 2 is 6. We are going to get 3 exponent 2 by 2 is 4. We can simplify this further, right? We can simplify this further. Down to this, right? Let us continue here. Now 2 exponent 6, we can simplify, right? Now whenever you have something like this, it means the index notations are multiplying each other, all right? When you have a number exponent something, another number exponent something, it means they are multiplying, all right? So let's solve for 2 exponent 6, and then let's solve for 3 exponent 4, and then let's multiply, right? So 2 exponent 6 means 2 multiplying itself 6 times. 2 multiplying itself 6 times. So we have 2 times 2 times 2 times 2 times 1, 2, 3, 4, 5, 6, right? Times, remember I said when you have something like this, it means they are multiplying. 3 multiplying itself 4 times. So we have 3 times 3 times 3 times 3. Good. 2 by 2 gives us 4. Multiplication sign comes. 2 by 2 gives us 4. Multiplication sign comes. 2 by 2 is 4 times 3 by 3 is 9 times 3 by 3 is 9, right? You have to follow the pattern so that you don't get confused, all right? The same approach. 4 by 4 gives us 16 times 4 by 9 gives us 36 times 9, right? Now let us multiply 16 by 36, all right? Let's do it together. 36 by 16. 6 gives us 36. 6 3 18 plus 3, you're going to get 21, right? 6 1 gives us 6. 3 1 gives us 3, right? 6, we have 7, we have 5. So 16 by 36 gives us 5 7 6 times 9, right? So 5 7 6 times 9. Let's do it together. 9 6 gives us 54. 9 7 gives us 63. Plus 5 gives us 68, right? So we have 5 9 45. 45 plus 6 gives us 51. So we have 5184. If you followed this far, congratulations, you are making progress, right? That is our answer for the last one. So with these examples, you can be able to solve any question revolving around index notations or the laws of indices in this simple form as you are seeing on the board, right? Now I'm going to give you another set that will be example 2, about 7 questions, and then you're going to solve on your own. Make sure you don't cheat. Stay tuned. I'm bringing the next set, right? This is the problem you are supposed to solve on your own. Make sure you work with speed and accuracy. Alright, they are very simple. You just apply the laws we've talked about, and then you will not find yourself wanting. Alright, make sure you pause the video and you work out the solutions. Alright,